Hey guys, in this video we are going to install 5.6 kilowatts grid-tie solar system. For this project we are going to use Q-cell solar panels, 350 watts each panel, and Enphase grid-tie micro-inverters. And I'm gonna show you step by step how to install grid-tie solar systems, so if you're interested, let's jump into the video. So the first step is going to be physically go to your roof and measure how many panels you can install there. With this particular installation, we need to install 16 panels and we have plenty of space on the roof to install this. Depending on your local code, you have to do certain space between edges of the roof. And right here we're installing 16 panels and we have plenty of the roof space to accommodate these panels. So right here I'm just gonna do quick layout of our panels. And here's a layout for 16 panels that we're going to install. So the next step is going to be to get permit for solar installation, and after a permit is acquired we can go into the roof and do installation. And now we're on the roof going to install a racking system. We're going to use Unirack brand, and the first step is to locate rafters and mount flashings between shingles to prevent any leakage. To locate rafters on the roof we're using rubber mallet, and by the sound you can hear where's the rafter going. In this particular case it was a little bit harder because that roof was sprayed with insulation from attic, and this insulation make it hard to hear where the rafter is actually going. So when we start drilling, you can see the drill bit is going too fast into the roof. That means we missed a rafter. And now we're just going to step 1 inch left and do another hole. And in this case we got right into the rafter. And now we have to repeat this step 32 times in this case. At this point we installed all flashings and L-foots, and now we can start rails installation. And here's example what you do when you need to extend your rails. You could use this splice bar just installed between two of the rails and extend for length that you need.
I'm gonna hold them. Battery is dead here. Battery is dead here.
Yeah. And when you swap it for the impact and using that one? After this,
Yes.
could you measure from the edge of the roof 36, well actually, could you measure from the, on the top rail,
Yes.
measure from the edge of the roof to the first rail,
Mm-hmm.
and then put all the others at the same,
Got this.
distance, 2 inches high from
From the roof.
the flashing to the bottom of the rail.
Got this. Okay. And tie them.
Yeah.
Okay.
With 9/16 sockets with the big black socket.
Okay.
And next step is to align all of the rails. So I'm measuring distance between edge of the roof to the rail, making sure it's same distance across all 4 rails. And we need to raise rail 2 inch from the flashing and tighten the bolts. And to make sure that all rails align perfectly, we just add another rail across our roof rails to make sure that all of them are aligned.
Voila!
After aligning all of the panels, we can start mounting micro-inverters. We're using Enphase IQ7 brand, and here's a connector that connecting micro-inverter to solar panel, and now we can just start mounting 1 micro-inverter per panel. after mounting all micro-inverters to the rails, we can start connecting all of them together. We're using this Enphase cable with connectors, and this cable is a 12 gauge wires, so it could support up to 12 panels. And because we have 16 panels, we have to run 2 arrays from the roof. I'm starting with the array of 10 panels, and I have 11 connectors, because when we're gonna jump from first row to second row, we will need extra length for the wire, so we're just gonna skip one connector. And now, going between row 1 to row 2, we have this plug here on a connector, which is weather sealed, and we're just skipping this connection and going with the next one to second row to connect next micro-inverter. And now I have a wire with 7 connectors. I'm going to connect all inverters together on a left array with 6 panels, and just organizing wires and connecting all micro-inverters together. After connecting all micro-inverters together, we have 2 sets of cables. One end of the cable we need to put special terminator, special cap to seal this, and the other side is gonna go to Enphase combiner box.
Like that.
Do we need to redo something?
Next step, we are connecting conduit between 2 arrays to run wire from one array to distribution box, which is going to be mounted on the left array.
You sure you want to record? Actually, let's put it lower.
This is what's happening when you record.
Why don't we record the other side?
And now I'm keeping connection on a right array to run wire in conduit into left array distribution box.
By the panel itself. Same. We're installing in an old neighborhood, and I put the Beatles on old school rock, because if you complain about the Beatles, like it's culturally inappropriate, so nobody can complain. And if I have youngsters, then I put newer music. And if it's raining, then I put Frank Sinatra.
And now I'm just pulling all of these stickers from micro-inverters and sticking them on a piece of cardboard, and we're gonna use this information later to set up micro-inverters in Enphase web interface. At this point, all wires secured with clips and zip ties were needed. Here you can see metal enclosure where we have one wire from left array and another wire from right array. And from this metal box, we're gonna run Conduit down into Enphase combiner box. And now time to move panels up.
I got this.
In general, solar systems installation is a pretty good physical exercise. And now we are connecting solar panels to micro-inverters and mounting solar panels into racking system. Organizing wires under the panels is the most time-consuming process, and I'm gonna show you two ways how you can organize wires. First way is just to roll all of them together and then use clips and clip these wires to the panel. And here's a second way, which I found much easier and faster. You just take two wires from a panel, twist them together, and then use zip tie to tie them to microinverter.
How's that look?
And now, before mounting last panels on the array, we need to run copper wire across rails to ground them together. On the second day, we are running conduit from the roof into Enphase combiner box and then into electrical panel. We're using half-inch metal pipe, and bending this pipe around all shapes of the house could take some time.
So example, I found this. the speed at which packages accumulate here is impressive. It's like there's like 4 deliveries today already.
Everything online. The next step after we're done with the conduit, we are sending fish tape down from the roof into the conduit, and we're gonna run wires.
Yep, it's here.
And now we can run wires into the conduit. And because we're using Enphase micro-inverters, they are producing 240 volts, so that means we don't need to run neutral to them. And because we have 2 arrays, so we have to run 2 sets of hot wires for leg 1 and leg 2. So here's why we're using 2 black wires and 2 red wires. And 1 green wire is going to be our ground, which is going to be connected to main electrical panel.
Okay, let me know when they're ready.
After pulling wires, we can start connecting line 1 and line 2, and the next step is just to crimp neutral line. And here's the final result. Now we can close the lid and move down into Enphase combiner box. So in the combiner box, first step what I'm doing is removing insulation from ground wire, and I'm going to connect this to a clip to ground our conduit. And after installing grounding wire, next step is to install 2 circuit breakers for each array, and you can see that we have to run black wire through CT sensor in Enphase combiner box, and now we have to run 4 wires from combiner box into electrical panel to connect our system. So it's going to be white wire for neutral, green for ground, and then black and white two hot wires to connect array to 240 volts into grid power. And this is panel from another setup. I was not able to record last steps of installation, so here's why I'm using 20 amps circuit breaker, because solar array here is 3.5 kilowatts. For 5.6 you have to use 30 amps circuit breaker. And basically at this point we can close panel, put appropriate stickers, and now we can turn circuit breaker and our solar system should start producing power. So right now when solar array connected to the grid power, micro-inverters will take 5 to 10 minutes to sense grid power and frequency. And right now on a smart meter you can see that my house consuming 360 watts. And now after about 5 minutes we see negative numbers on a smart meter. That means we are pushing power into the grid. Alright guys, that's all about this setup. I hope you found this video useful. If you have any questions, feel free to ask them in the comments. And as always, thank you for watching and see you later.